Ever gaze into the sky and wonder about the blazing ball of fire that lights up our world? What you're marveling at is the sun, our closest star, and a celestial body of immense power and importance. It's a vibrant powerhouse, ceaselessly churning out the energy that fuels life here on Earth, and it's been doing so for roughly 4.5 billion years. The sun is the heart of our solar system, a gravitational anchor around which our Earth and other planets orbit. It's like a cosmic lighthouse guiding us through the vast, dark expanse of space. And yet, for all its prominence and familiarity, the sun still holds many secrets, many layers of intrigue that we're only just beginning to unravel. Today we're going on a journey to the sun. We'll delve into its fiery heart, explore its turbulent surface, and traverse its magnetic fields. We'll learn about its composition, its cycles, and its curious phenomena like sunspots and solar flares. We'll even look into the sun's future and ponder the fate of our beloved star. This journey won't be easy. The sun is a harsh and unforgiving environment, with temperatures hot enough to melt steel and pressures that dwarf anything we experience on Earth. But it's also a place of beauty and wonder, a celestial spectacle that's been captivating humans since the dawn of time. And as we embark on our exploration, we'll discover just how astonishing the sun truly is. From its sheer size and mass, to its incredible speed of rotation, from its extreme temperature to its powerful gravity, the sun is a marvel of nature, a testament to the cosmic forces that shape our universe. And as we unravel its secrets, we'll come to appreciate not just the sun itself, but also the intricate and delicate balance that allows life on Earth to exist. So are you ready to dive into the heart of our solar system and uncover some astonishing facts about the sun? Did you know that the sun is essentially a giant glowing ball of gas? It's true. The sun, our closest star, is primarily composed of two elements, hydrogen and helium. Hydrogen makes up about 3/4 of the sun's mass, while helium accounts for most of the rest. These two elements are not just randomly mixed together. They're hard at work. You see, the sun's core is a hotbed of activity where these elements undergo nuclear fusion. Imagine countless hydrogen atoms colliding and combining to form helium. This process releases a staggering amount of energy, which we see and feel as sunlight. It's not unlike how we generate power in nuclear power plants, but on a much, much grander scale. The sun's composition and the process of nuclear fusion are what make life on Earth possible. They provide the heat and light we need to survive. Yes, the sun is more than just a bright light in the sky. It's a powerful nuclear reactor. Have you ever heard of the sun's 11-year mood swing? That's right, our sun, the constant beacon of light and warmth, isn't as steady as it seems. It goes through a cycle known as the solar cycle, every 11 years. During this cycle, the sun's magnetic field flips, causing dramatic changes in solar activity. At the peak of the cycle, known as solar maximum, sunspots and solar flares become more frequent. These are areas on the sun's surface that are cooler and less active than the surrounding areas, and sudden bursts of energy respectively. As the cycle progresses, the sun calms down, leading to a period known as solar minimum, when sunspots and flares are less common. This ebb and flow of solar activity has far-reaching effects, affecting everything from satellite communications to Earth's climate. So the sun isn't as constant as it seems. It too has its ups and downs. Ever spotted dark spots on the sun's surface? These are known as sunspots, and they're not just random blemishes. Sunspots are cooler areas on the sun's surface, caused by intense magnetic activity. They're like the freckles of the sun, but instead of being caused by UV rays, they're born out of the sun's own tempestuous nature. Sunspots don't just appear at whim. They're intimately linked to the sun's solar cycle, a roughly 11-year period during which the sun's magnetic activity waxes and wanes. At the peak of this cycle, the sun is often adorned with a multitude of sunspots, a testament to the heightened magnetic activity taking place beneath its fiery surface. Although they may seem insignificant, these sunspots play a key role in our understanding of the sun. They provide a window into the sun's internal workings, revealing the complexity of our closest star. Intriguing, isn't it? These dark spots tell us more about the sun than its bright light ever could. Imagine an explosion millions of times more powerful than a nuclear bomb. That's a solar flare for you. Solar flares are massive eruptions that happen on the surface of the sun, where magnetic energy is released in the form of light, heat, and particles. These flares are born when the sun's magnetic field lines twist and snap, releasing a colossal amount of energy equivalent to millions of nuclear bombs. This energy then propels outwards, creating a spectacle of intense light and radiation. But what does this mean for us on Earth? Well, when these particles reach our planet, they can cause a variety of effects. On the more benign side, they can create beautiful natural light shows known as auroras. However, on the more severe end, they can interfere with our technology, potentially causing blackouts and disrupting communication systems. So, while they may be a spectacle to behold, these solar flares remind us of the sun's immense power. Solar flares are the sun's fireworks, spectacular yet potentially dangerous. Can you guess the sun's age? A question that has intrigued scientists for centuries. Our radiant orb of light is approximately 4.5 billion years old, a middle-aged star in the context of cosmic time. It's currently in a phase called the main sequence, where it's been for about 90% of its life, steadily converting hydrogen into helium. But what's the future looking like for our fiery celestial neighbor? Well, in about 5 billion years, the sun will exhaust its hydrogen supply and expand into a red giant, engulfing the inner planets, yes, including Earth. But don't worry, we have plenty of time before that happens. Finally, it will shed its outer layers and leave behind a dense core, a white dwarf that will cool and fade over tens of billions of years. So, the sun has been around for a while, and luckily for us, it's not going anywhere anytime soon. Did you know the sun is a fast mover? That's right, our closest star is quite the speedy marvel. It actually rotates or spins on its axis, much like Earth. But, unlike our planet, which completes a full rotation in approximately 24 hours, the sun takes its sweet time. A full solar rotation takes about 27 Earth days at its equator. But here's the kicker. The sun's poles rotate even slower, taking about 36 Earth days. Now let's talk about the sun's orbit. The sun, along with the entire solar system, orbits the center of the Milky Way galaxy. And it's no leisurely stroll. It's hurtling around at an astounding speed of approximately 448,000 miles per hour. That's over 100 times faster than a bullet shot from a gun. So while the sun might seem stationary to us, it's actually spinning and moving at incredible speeds. Just how big do you think the sun is? Now let's unravel the true ginormity of our closest star. Picture Earth, a sphere with a diameter of roughly 8,000 miles. Now imagine over 1 million of these Earths. Yes, you heard it right. Over 1 million Earths could fit inside the sun. Its diameter, a whopping 869,000 miles. This might be hard to fathom, but let's take it further. Comparing the sun with other celestial bodies, it's not even the largest star in the universe. There are stars like Ui Scuti, which are over 1,700 times larger than the sun. But don't let this dwarf our sun's significance. In our solar system, the sun is undoubtedly the behemoth, accounting for 99.86% of the total mass. It's so large that its gravity keeps all the planets and other celestial bodies in check. The sun might look small from Earth, but it's actually a giant among stars. Ever wonder why planets, including Earth, orbit the sun? Well, the answer lies in a force we're all too familiar with, yet often overlook: gravity. The sun's gravity, to be specific, is the unsung hero of our solar system. You see, the sun is not just a bright, glowing ball in the sky, it's a massive celestial body, over 300,000 times the mass of Earth. This massive size gives it a gravitational pull so strong that it keeps all the planets of our solar system in their orbits. Imagine the sun as a large, invisible magnet, pulling everything towards it. This gravitational force is what keeps Earth and other planets from hurtling off into the vast expanse of space. It's like a cosmic dance, with the sun leading the way. But the sun's gravity doesn't just keep planets in place. It also affects life here on Earth in ways we might not even realize. It influences our tides, causing them to ebb and flow. The sun's gravity also plays a key role in climate and weather patterns, helping to shape our planet's diverse ecosystems. And let's not forget its role in space exploration. The sun's gravity has been used to propel spacecraft on their journeys, a technique known as gravity assist or slingshot effect. It's like hitching a ride on a cosmic roller coaster, using the sun's gravity to gain speed and conserve fuel. So, while we may take the sun for granted, seeing it as just a source of light and warmth, it's doing so much more. It's the solar system's glue, holding everything together with its gravitational pull. It's the reason why we're here, orbiting in this precise spot in space, able to exist and thrive. The sun's gravity is a testament to the interconnectedness of the universe. It's a reminder that even though we may seem small in the grand scheme of things, we're all part of something much larger, something beautifully complex and wonderfully orchestrated. The sun's gravity is the invisible string that keeps our solar system together. Can you handle the heat? Because the sun certainly can. Our nearest star's temperature is mind-blowing, even by cosmic standards. Inside its core, where nuclear fusion occurs, the sun blazes at a staggering 27 million degrees Fahrenheit. It's so hot that it makes hydrogen atoms collide and fuse into helium, unleashing tremendous amounts of energy. As we move outward, the temperature drops. The sun's surface, or photosphere, is a comparatively cooler 10,000 degrees Fahrenheit. That's still enough heat to make any visit a one-way trip. But the sun's temperature doesn't just stay there. It radiates outward, bathing our planet in warmth. This heat is essential for life on Earth, providing the energy for photosynthesis, driving our weather systems, and making our planet habitable. It's a delicate balance, but one that our sun has maintained for billions of years. The sun's heat is a powerful force, fueling life on Earth and driving our weather. Have you ever wondered why it takes about 8 minutes for sunlight to reach us? This fascinating phenomenon is all due to the speed of light, which is, remarkably, about 186,282 miles per second, or nearly 300,000 kilometers per second. Imagine, if you will, a cosmic race between a beam of light and a jet plane. The jet plane, flying at a brisk 600 miles per hour, would take over 16 years to travel from the sun to Earth. The light, however, would cover that same distance in a little over 8 minutes. That's faster than you can make a cup of tea. But what does this mean for us? Well, it means that we see the sun as it was about 8 minutes ago. If the sun were to suddenly disappear right this moment, we wouldn't notice until 8 minutes later. It's a mind-bending concept, isn't it? Now let's delve into how sunlight travels. Sunlight, or more scientifically, electromagnetic radiation, is emitted by the sun's surface. As these photons of light escape the sun's gravitational pull, they race across the emptiness of space. And voila! Just over 8 minutes later, these photons arrive here on Earth, providing us with light and warmth. This light from the sun is the primary source of energy for all life on Earth. It's responsible for photosynthesis in plants, which in turn provides oxygen for us to breathe and food for us to eat. Moreover, the sun's light is vital for our climate and weather. It heats our world, driving the winds, the rains, and the currents in our oceans. It's even responsible for our seasons, as the Earth's tilt determines how much sunlight each hemisphere receives throughout the year. So, the next time you bask in the warmth of a sunny day, remember that the light tickling your skin embarked on a cosmic journey, traveling millions of miles at unimaginable speeds just to reach you. The sun's light, a beacon that takes just over 8 minutes to reach us, is our primary source of energy and life. So what are the top 3 most astonishing facts about the sun? First, let's talk gravity. The sun's gravity is about 27 times stronger than Earth's. That's right, if you could somehow stand on the sun, without being incinerated, of course, you'd weigh 27 times your current weight. Quite a workout, isn't it? Next, we've got temperature. The sun's core is unimaginably hot, reaching a mind-boggling 15 million degrees Celsius. To put that into perspective, that's over 2,600 times hotter than the hottest lava on Earth. Now that's some serious heat. Finally, the sunlight we enjoy every day actually takes over 8 minutes to reach us, despite traveling at the speed of light. That's because the sun is about 150 million kilometers away. So, when you're basking in the sun's rays, remember, you're experiencing a glimpse of the past. Amazing, isn't it? The sun, our closest star, is a lot more fascinating and complex than it seems. Before we wrap up, let's take a moment to acknowledge the shared curiosity that brought us all here. If you've learned something new from this video, then we've achieved our goal. We'd love it if you could show your support by giving this video a like. Do you have thoughts or opinions about what you've learned? Share them in the comments section below. We're always eager to engage in enlightening discussions about the wonders of our universe. Also, don't forget to hit the subscribe button and the bell icon to stay updated with our latest content. We regularly explore fascinating topics just like this one. And lastly, if you found this video interesting, why not share it with your friends and family? Let's spread the knowledge and foster a community that's as passionate about the cosmos as we are. After all, the sun shines for everyone. Until next time, keep looking up and stay curious.